Hello and welcome back to another LeetCode video. Today we're looking at LeetCode 2043, Simple Bank System. I think this should actually be an easy problem. However, on LeetCode it's rated as a medium one. But as you will see, it's quite straightforward to solve. So let's dive into it. What are we dealing with here? So we are asked to write a program for a popular bank that will automate all of its incoming transactions, transferring, depositing, and withdrawing of money. The bank has n accounts numbered from 1 to n. That is important, that it's not starting from 0. The initial balance of each account is stored in a zero-index integer array balance, where the I plus 1th account having an initial balance of whatever the value is inside the array at the ith index. And you can see here in the constructor we're giving the balance array. Now, we must execute all valid transactions, and a valid transaction is when the given account number is between 1 and n, and the amount of money withdrawn or transferred is less or equal, is less or equal to the balance of the account, right? We can't withdraw money if it's not in the bank, and we can transfer it if it's not in the account we want to transfer from. And we must implement the bank class. And the bank class has these four methods. The first method is where we initialize the bank with all of the initial values for the balances for all the different accounts. Then we must implement a transfer function that should return a bool value, whether the transfer was successful or false, and should transfer the money from one account to another account and return true if the transaction was successful, false otherwise. Next, we should implement a deposit function where we're given an account ID, and we have to check if it's a valid account, and then we will deposit money into that account if it's a valid account. And here as well, we need to return true if the depositing worked and otherwise false. The account is not a valid account ID, then of course we need to return false and not put any money in any of the accounts. Last, we need to implement the withdraw function. The withdraw function transfers, it withdraws money from an account, so we have to check whether the account ID is valid and whether the account has enough money that we can withdraw from it. And that's really it. So I don't think there's a big algorithmic challenge here. Some constraints that might be interesting. So n is the length of the balance array, which represents how many different accounts we have from 1 to n. Then the initial balance given is 0 or larger than 0. And the money that we're given in any of the function calls is, I guess it's also between 0 and some high number. So it's never going to be negative, which is good to know, so we don't have to deal with that edge case. At this point, I don't think I need to look at any of the examples to understand what to do, but maybe we should do it real quick here, just for the sake of completeness. So here we give it an input and an output. You can see here the input is organized such that the first is going to be calling the constructor. So this is the initial, are the initial balances for all of the accounts. And you can see we have 5 different accounts here. Then we withdraw money from account number 3, and we try to withdraw 3 units of money. So this is count 0, 1, 2. So we're withdrawing 10, whatever the denomination of the money is, from an account that has 20 in it. Then we're going to transfer money from account 5 to account 1. And so there's 1, 2, 3, 5, 20 to 1, 100 becomes 110. And so on, and so on, and so on. Right. Well, so when you get a question like this in an interview, it's more, and you can kind of see it's not really an algorithmic challenge. It's really more about, can you design your code in a sensible way? That's mostly what it's about. Can you show that your code is logic, that you abstract things that you can abstract, and can you implement, can you maybe deduplicate code and isolate functionality that your different functions need into their own little helper functions? And that's exactly what we need to do here. I think the first step is quite straightforward. We need to, well, store a copy of the balances to start with. So I would just copy that. I would ask the interviewer, can I just take this, or do I have to make a copy of the whole thing? Like so. So for now, I would guess that we just have to make a copy. So this is a way to make a copy in Python. You can also just say copy that does the same thing. And well, next, what do we do next? Well, I think it would be useful to know what our number n is, because we need to check, when we call any of the other methods, we need to check whether the count ID is valid. So I think it's useful to have the length of the balance array in its own variable. Of course, we always compare it against the length of the balance array to get n, but I think it's more convenient to have it here. So we just store it. Right, and I think that's all we need to do in the constructor. Now, I guess the easiest function to implement is maybe the deposit function, because we're only adding money. We don't need to check whether there's enough money in the account, but we do need to check whether the count is valid. And so we could do this in here, right? We could have a little check if 1 is smaller or equal than account, than account, and account is smaller or equal than self.n. Then it's fine. Then we could say self.balance, and then we take the count and we add the money to it, right? Now we are going to have to do this check over and over in any of these other two methods that we have. What I propose is that we take this code and we put it into its own little helper function. So maybe is valid account. Account, and in an interview I would probably say that I'm not going to add type hints, but I would do in production. That's just to make it faster for me to type stuff during an interview. This time is limited, so you kind of really want to speed things up, but explain to the interviewer why you're taking shortcuts if you don't type hints, etc. And yeah, so now all we need to do is we just have to, well, return if 1 account and account smaller or equal than n. So that will return true whenever the account ID is valid. So in our little deposit function, we will do if is valid account, and we pass in the account ID. In that case, we're going to add money to the balance sheet, and we need to return a bool value whether the action to deposit money was successful. And otherwise, we have to return false. Now, since our accounts start from 1 to n, we actually have to correct the index that we access. So we actually have to correct by -1. Because remember, in Python, arrays the first position in an array is at index 0. And the last position of an array is at the length of the array -1. So we have to correct the index to access the right one count in the balance array. Right, and that is everything that we need for the deposit function. Now, how about maybe withdrawing seems to be the next easiest function to implement. And I think what we can do here as well, we just reuse our little isValidAccount function. If it's not a valid account, we have to return false. But if it is a valid account, we now have to check whether there's enough money on it. And with checking if there's enough money in the count is going to be something that we need both in the withdraw method and in the transfer method. So I propose again, let's put that into a little helper method. Can withdraw. And then we just pass in the account. And we're also going to pass in the money, right? And we're going to return a bool, tell you whether it works or not. Now, can withdraw, we could directly check, for example, we could say if self.balance at account -1 is larger or equal than money, right? And we could just return this as the true value. However, we should also still check if it's a valid account, just to be safe, in case anybody uses our can withdraw method besides ourselves later. That's just good design, just to guard against an index out of bounds exception when somebody calls this method with an invalid account ID, right? So what we'll just do, we just pass that account ID to our little function, and we just pass it. So it does this check, is it a valid account, and can we withdraw? Now here you could argue that, you know, you could just replace the is valid account with simply it can withdraw account money. That's nice, it simplifies things for us. Well, in that case, what we do is we just withdraw the money. We just minus equals minus and return. Right, so now we're almost done with the whole implementation. And what we'll do is now, well, implement the transfer function. And what do we need to check here? Well, we need to check if both accounts are valid and if we have enough money in the first account, right? So basically, we have to check, and now this is where the magic of reusing our code is. If we can withdraw money from the first account and is valid account the second account, if that is, oops, account 2, if that is the case, well, then we can actually withdraw and deposit self.withdraw account 1 money, and then we do the self.deposit into account 2 money. Return true because it worked, otherwise we return false. Right, so yeah, so coming back to what I said initially, you see we have our 4 functions, and we've implemented 2 little helper methods that just make our code so much more readable. And in an interview, you know, generating readable code and easy to follow code is one of the dimensions that you're going to be evaluated on. It's not just whether you get the right problem solution or the most effective solution or the optimal solution or whatever. It's also about writing good idiomatic code that is easy to follow. And I think this is pretty okay. We guarded against misuse of our can withdraw function. We broke out the repetitive logic of checking whether an account is valid and whether we can withdraw money into helper methods. You know, so I think this would be just fine. In terms of runtime and space complexity analysis, well, since this is not really an algorithmic problem, you know, it's kind of redundant to do that. I mean, all of these functions are all of one time and all of one space. We're never going to extend the number of accounts. No, we didn't to perform any complicated logic. The only thing that requires O of n time to O of n space is our initialization. That is only because we copy the entire array. If we just copy the reference to the balance array, then this is also O of 1 time and O of n additional space. Sorry, O of 1 additional space. So yeah, everything's basically O of 1 time and space, right, without the copying. Cool. So let's just run through the test to see whether I made any syntax errors here. Hope I didn't. And it looks like that is correct. And now let's submit this, see whether it passes all of the tests. And there you go. That's how you would solve this type of problem in an interview. You're looking for clarity and for good code style. That's all.